Hey everyone. Thanks for joining me for this session. Great to be back here at KCD Munich. And this year I'd like to talk to you about platform engineering. And before I start, just to get to know the people here, who of you has platform engineering, shared services, whatever it's called in your organization, has it in your organization with a show of hands? Great. Now leave your hands up. Out of these, how many of you work for an organization of 100 employees or more? 500 employees or more? 1,000 employees or more? 3,000? 5? Look around you. Look around you and remember that? 10,000. Okay. Remember that. That'd be very, very relevant for us in the discussion now. So, platform engineering, let's admit it, it's pretty hyped. Funnily enough, and I didn't pay Gartner to do that, just last week, Gartner released its annual hype cycle, a series of hype cycles, and surprise, surprise, platform engineering is there at the famous or infamous, depending on how you see that, peak of inflated expectations. That's from the containers one. You'll see the same on SRE and others. And yeah, admittedly, it is hyped. One of the things that I take out of that is optimistic is that it's actually coming out of the peak of inflated expectations. So Gartner expects it to be getting out of the hype, which is, by the way, also what I expected when they asked me what my predictions are for this year, for 2024. Back in the end of 2023, I said that this year, 2024, would be the year that platform engineering goes past the hype and into production grade. So yet to be proven, and that's part of what we're going to talk about today. My name is Horovits. I'm the principal developer advocate at logs.io. Logs.io provides a cloud-native observability platform that's based on popular open source tools, many of which we hear here in the KCD and the cloud-native sphere, such as Jaeger and Prometheus and others, and OpenTelemetry, and that provides it as a scalable platform managed for you. So if you have any questions about Logs.io, feel free to grab me after the talk. It's not the topic of this talk. I'm also a CNCF ambassador. CNCF is the Cloud Native Computing Foundation. We're at the KCD, so everyone knows the CNCF. So if you have questions about the cloud native stack, also happy to talk about it after the talk. And as you can see on the tweet here on the screen, I'm also a platformer. So this is the reason I'm here with you today. I also have a podcast called Open Observability Talks about open source, DevOps, observability, and the like. So if you like podcasts, it's in English. Check it out on your favorite podcast app or on YouTube. And as you can see, you can find me everywhere at Horovits, Twitter, Mastodon, Medium, LinkedIn, whatnot. So if you're tweeting or tooting or posting anything out of this talk, feel free to tag me. And now, before talking about platform engineering, let's talk about the challenges of DevOps that we come to solve with platforms, and primarily for DevOps at scale. So as the organization grows and you have multiple products, multiple product lines, business units, lines of business, and the like, then these problems start arising. Firstly, the toil, okay? You figure out very, very quickly that different teams across the products, application teams, and so on, solve the same problem again and again and again in a silo, without any, oftentimes without any knowledge of the other team already solved the problem, or if they are aware of that, the other team solved it so tightly coupled with their own product and implementation that it's too much of a hassle taking it from them. They rather start it from scratch. So that's the toil and waste part. The other problem is the cognitive load. Okay, we all praise the shift left movement, but let's face it, the shift left comes with the baggage. Okay, now the developer needs to know Kubernetes and Docker and Terraform and Jenkins and Postgres admin and whatnot. And that's a major cognitive load for developers. And it's also a major defocus, because that developer needs to now spend 40, 60% even of the time on all these infrastructure-related concerns, rather than focusing the majority of its time on the actual business logic that he or she are there to implement. Okay? So that's the defocus. And the last challenge here, as you can see, is the fragmentation and inconsistency, because there is now in the organization multiple ways. There are multiple ways to solve a problem. There's no one recommended way. There's no golden path for that. If an engineer comes and say, okay, what is the way that I should install my environment? You have a gazillion ways that you can find. And it gets confusing. And also, it's very hard to enforce conventions, security, compliance, and the likes across the organization, because everyone implements it in silo. So these are the challenges. And the answer is, the premise is the following. Don't reinvent when you can reuse and adapt. That's the basic premise of platform engineering. Actually, I had a conversation with that just last night with a fellow speaker from the speaker dinner. That's what we were talking about. He's a chief architect in a large corporate, and that's the thing that resonated most. Don't reinvent when you can reuse and adapt. And that's what platform engineering is for. So let's talk about what platform engineering is. And I didn't bring a formal definition. I saw several definitions out there. I didn't like any of these. So I brought mine, and actually I just broke it down to the main takeaways that are of interest to you. So platform engineering is a DevOps approach in which organizations develop a shared platform to improve the developer experience and developer productivity across the organization by providing self-service capabilities with automated infrastructure operations. Now, again, let's break it down to the main takeaways that we want to focus on. First and foremost, it's a DevOps approach. It's not a whole different beast. It's not a new creature. It's just a DevOps approach. Secondly, the main goals are to improve the developer experience and the developer productivity. And we do that by providing self-service services, essentially, provided across the organization. Okay? That's the idea. Now, this is the definition, but let's take one concrete example to make it very concrete. And for that, I used actually an example that I heard from a director of platform at Citrix at the time. I had a fascinating episode with him on my podcast, Open Observability Talks. You have the QR code here for those who want to listen to the episode and hear it firsthand. And I really liked it because it really lays out the classic dynamics of platform engineering. So let's look at this case study of certificate rotation. So it started by realizing, the platform engineering team realized that different teams essentially invested significant time in implementing certificate rotation for themselves, each one independently and in silo. The next step, and it's very important, they didn't go about straight away implementing something. They went to the teams, or at least the let's say, call it design partner teams, and approach them to try and assess the benefit. So they realized in their case that the effort that they have put is 300 story points, and that they can reduce it to only 50 story points if it's just integrating with a service, platform service. Okay, then that's the saving for one team, now multiplied by the number of teams in the company. Then once they got the buy-in, they went ahead and implemented this as a shared service, certificate rotation as a service, provided across the organization. That's a classic dynamic that you would be looking for platform engineering. So you've seen from my definition that platform engineering is not a whole new beast. As I mentioned before, it's simply an approach, a DevOps approach. So what is the relation between DevOps and platform engineering? I see a lot of confusion about that and lots of questions that people come to me. So I wanted to show a couple of slides to try and get that in place. So DevOps, we all know DevOps. DevOps essentially uses tools to streamline deployment and management and monitoring of our applications with automation, visualization. These are the classic DevOps, right? So platform engineering takes these tools, processes, and best practices and productizes them as reusable services across the different engineering teams, across the different use cases within the company. And remember, the operative word here is to productize them, okay? And I'll touch upon that very soon. Another way that makes it easier to explain platform engineering with regards to DevOps is looking at the DevOps maturity lifecycle, as we find it in typical books and so on. Initial, managed, defined, measured, and optimized. That's a classic maturity model. And when we look at it, when you're in the earlier stages, the managed, defined, we find typically teams that create their own DevOps practice to fit the needs of that team. We see usage of blueprints, such as Terraform templates, modules, Docker images, and so on. And then engineers clone, fork, and do the configuration, but then they get detached from the origin. Okay? For those who were in Philip's talk just before mine, I don't know if Philip is still here, but he gave very good examples. If you look at Customize, he talked about Customize as package management, and what's the problem that people actually started leaving Customize. That's exactly that. So you try to patch the manifest, but then when you do that at scale and you fork it, and then you get detached from the blueprint, from the manifest, then it's very difficult for centrally supporting that going forward. So, and same with Helm and others. So these are the sorts of challenges in these phases. And then, as your DevOps matures, as the organization scales and DevOps matures and you get into the measured and optimized phases, then the organization starts measuring and monitoring the impact of DevOps, and then this measuring starts exposing these pockets of inefficiency. For example, these teams, the toil that gets wasted for doing the same work again and again, and then the importance of efficiency of running it at scale, and the automation and the centralization becomes very evident, and then it becomes very clear that platform engineering is material to the organization. And Spotify is a great case study for that. Spotify developed their own internal platform for their own engineering organization. In fact, they later released, open sourced, and released it under the name Backstage. So it's now an open source under the CNCF. I'll probably touch upon Backstage if time permits at the end of the talk, but you have a QR code here that you can scan, and which another episode that I had with a director of engineering at Spotify that discusses exactly why they implemented internal platform and what the benefit. But you can see a summary here, so you can talk about 2.3 times more active on GitHub, created 2 times more code changes in 17% less cycle time, deploying software twice as often, and their software is deployed for 3 times as long. And last but definitely not least, 5% more likely to be at Spotify 1 year later, because let's face it, the cognitive load comes with a price, and the employee churn, especially the quality employees that don't want to waste their times on these boilerplate stuff, is important. So I say shared services, I repeated it several times, but it rings a bell, right? It rings a bell from whoever remembers platform as a service. Who remembers platform as a service? With a show of hands? Okay, we have quite a few here. And who uses platform as a service, one kind of that, like Heroku or AWS ones or Google one today? With a show of hands? Okay, so we have quite a few. Interesting. So platform as a service, for those who don't know, back in the day, about a decade ago, we used to line up the stack very neatly between IaaS, infrastructure as a service, platform as a service, and software as a service. And infrastructure as a service back then was pretty mature, especially AWS. So you got compute, network, storage, whatnot. And then software as a service, everyone wants to build its application on top of that. But then they realize the gap is very big. Like, I want to build my new e-commerce straight on top of the IaaS. That was a lot of gap to fill. And this is the gap that platforms such as Heroku, AWS Elastic Beanstalk, Google App Engine came in and became a hot topic. But as you can see, many of us today do not use that. And then the question comes in, is platform engineering just PaaS all over again, rebranded? And I've been there. I've lived through this. I actually even worked at a startup that was called Cloudify, later acquired by Dell EMC, that was squarely about this topic. So I've lived through that, and I've seen the mistakes that we've done with PaaS. And my take on that is that, no, platform engineering is not PaaS all over again. So I want to look at a few things that I think PaaS missed and prevented the wider adoption, and what platform engineering takes a different approach to. The first one is that platform PaaS was very opinionated. Okay, it's very easy, right? It's PaaS meaning I get one instance of a data store, one instance of a message bus, one instance of that, and I wire my application with these abstract entities. It's very, very elegant and simplifies things, but I need to align with this simplified, holistic stack. And it was difficult back then. It's even more difficult today when organizations have so many different runtimes, deployment methods, and so on. Also, it got a bit of a vendor lock-in issue because, if I wired my infrastructure based on Heroku, then I'm locked into Heroku, which is some problem. And also, related problem is that what happens with my assets. So I have all the Terraform, Docker, configurations and stuff like that. Can I no longer use them? Or how do I migrate them? What do I do with them? So it also created the challenge in that respect. These were the challenges. And as I said, I think that this was not the right approach, definitely not for today's cloud-native architectures. The fact being, if you ask me, we don't need platform as a service. We need platform as a product. And maybe because I used to be a product manager in past life, but this is something material to a successful platform engineering. And how is that different beyond the buzz? So first of all, platform engineering is developed in-house. Okay, you have an in-house team, engineering team, sitting shoulder to shoulder with your product teams so that they can make sure that the platform suits the organizational conventions, tooling preferences, development and deployment styles, compliance constraints, and so on. And also, very importantly, the approach with internal platforms is optional and composable. You don't have to be bought into the whole vision and the whole set and all the components to be able to use it. Teams can choose to use individual pieces, individual components, individual managed services out of the stack without taking the whole thing. So remember that, composable and optional. Treating your platform as a product starts with treating your engineers as your users. Okay? And remember that. There's a room for product sense in that respect, and I want to break it down. Again, it's very, very important for successful product. So what does it mean? First, user research. Treat your engineers as your users. The fact that they're in the same organization doesn't mean that you understand them. Don't assume that you understand their day-to-day and their pain. Sit down with them, understand their pains, understand their needs, understand their day in the life of a user, and then derive the features and the roadmap from their needs, pains, wishes, okay? Secondly, be data-driven like any product. Make sure that you quantify the value and measure the success. Obviously, you can't measure that with maybe dollar signs of sales because it's internal users. Still, find the right KPIs to measure the success based on your criteria. And very importantly, balance the simplicity with the flexibility. Because engineers are very complex beasts. On the one hand, they want simplification, right? I don't want to know all these nitty-gritty details of Kubernetes. Hide it from me. Give me one thing, a cluster that works, and get rid of all the details for me. That's a simplicity. On the other hand, engineers like the control, right? So, well, in Kubernetes, I could do kubectl minus this and that, and I can do that. Are you saying that you're hiding it from me? No way. Yeah. So, as product managers needing to have one platform to rule them all, we need to strike the right level of abstraction between these two conflicting ideas. So we talked about needs arising from the engineering teams, the different platform teams, app teams. Now, there are also needs that are cross-functional, cross-organizational needs that platform engineering teams need to address. I brought some examples here. So if you remember, when each team re-implemented its own thing in a silo, it was very difficult to now enforce some security, compliance, and things like that. Now that we have a platform, it's much easier. So that's a distinct benefit of platforms. And so the aspect of maintaining compliance with relevant regulation standards, that's one benefit. The other one is establishing conventions, cohesive developer experience with consistent conventions, standards, style guides, things like that. There's another dimension of cost efficiency. When each team chooses its own stack, you can work in 1,000 or 5,000 size organization, but you don't have leverage because you're just a small team using this tool. When you consolidate and come as organization-wide into the vendor discussion, you can get significant reduction in prices. Or you can do some sort of multi-tenancy across products, across product lines, and so on, when you have one team to rule them. So all these FinOps considerations become much easier to manage when you do that holistically as one organization. And the last part is reducing the headache, the overhead, by instilling best practices and golden path solutions. So this is the cross-organizational benefit. And now that we understand the platforms, I want to go very quickly about the capabilities that the platform provides. And for that, I used the model that we established with a white paper issued by the CNCF, by a working group designed created for platforms. So you have the QR code for the white paper. For platforms, there's another white paper about the platform maturity model. So very interesting, by tag app delivery. So do follow the pages. I want to very quickly use this model to go over what the platform provides. And it starts obviously over the infrastructure, AWS, public clouds. It could be OpenStack or private clouds or whatnot. This is the baseline layer. And then on top of that, we layer the platform capabilities. It starts with environment and resource capabilities, covering the runtime environment, Kubernetes infrastructure, databases, caching, messaging queues, and so on. There's also the software release pipeline, the build, CI/CD, think about Jenkins, Argo, Flux, and so on. Even the chaos engineering elements. We can even talk about developer environment. Imagine how much time a new employee coming to your engineering needing to set up his or her environment before they start being productive. Now, if you can provide that as a managed service with a click of a button, or even you when you need to reboot your laptop, happened to me a few times, not nice. So all of that, obviously on top of that, security related like identity, RBAC, AAA, static code analysis, artifact scanning, we can bake it into the platform so that it's not up to the individual developer to know whether they hook it up or not. There's also the observability. I come from the observability space, as I mentioned before, working at Logs.io. So all of the full life cycle of observability, from the instrumentation of your code through the different enrichment, local daemons, collectors, the sampling, aggregation, storage, visualization, alerting, downstream into PagerDuty or whatever, incident management, all of that can be baked into the platform. So the engineer doesn't decide whether they want telemetry sent or not from their application, as an example. So all of that in observability, and obviously it can be many more. You see some examples here. And on top of the components, there's the interfaces, whether UI, API, or CLI exposed from the platform. So just to summarize, just before I summarize, that's the Backstage platform. You have the QR code here for more. It's an open source under the CNCF these days, started from the work at Spotify as an internal platform. You see the metrics, very good metrics of adoption and activity around the GitHub and so on. So really interesting. If you're looking for an open source under the CNCF stack, this is a definite candidate to look into. And now to summarize. So start with this one, and if there's one thing to take out of this talk, take this one. Don't reinvent when you can reuse and adapt. So platforms are meant to improve the developer experience and the developer productivity by removing toil and cognitive load. That's the direct benefit to the individual product teams. Then there's the centralized value of promoting org-wide consistency, security, and cost efficiency. And you see the pain growing as your organization grows. So the larger your organization is, the more the more product lines and so on, the more material it will become to your organization. So if you're small enough, don't try to impose it early enough. It should come out of the needs that we talked about. And remember, treat your platform as a product. This is an article I wrote about a couple of years ago about platform engineering that covers a lot of these topics extensively. So if you want to read more about this, check out this article. Brings a lot more information about the topics I discussed here today. And with that, I'm Dotan Horovits, and thank you very much for listening. And we have time for 3 questions. So who wants to take a shot? Who's the first brave one to ask a question? Come on. Or to challenge me. It's OK to also challenge any of my assumptions about what platform engineering is, because it's a new topic. I'll give you a sticker. Oh, OK.
I mean, it's hard to predict the future, right? But do you think there's maybe, you said like we had platform as a service, now we have platform as a product. Do you think there's a circle back to say like, since we learned a lot with platform engineering, that suddenly new products spin up and say like, hey, you can do this as a service once again?
Service that's like a third-party service?
Yeah, exactly.
So the reason I don't think is what I said before, why I don't think that platform engineering is platform as a service, because of this need to be very closely related to your organization. So off-the-shelf product, that's what we tried a decade ago with platform as a service, with things such as Heroku and so on. And as you can see, for some organizations, it's enough. If you can align all your organization with one methodology, one philosophy, and it fits all the different products, different product lines, different lines of business, it's fine. So it's much simpler to work with Heroku, AWS, Elastic Beanstalk, and so on. It's just that the diversity that I see in organizations that I work with is so large. You see different teams, almost like different companies inside the same company, and the diversity is so large that trying to align them all is too strict. So that's why I feel that, especially with the complexity of today's cloud-native architectures, that it's less of a fit to most organizations. But if you can, it's a simpler approach, that's for sure.
Thank you.
Any other questions? Here we go. We have a question there on the other side. He's getting him running. And while you run, I forgot to mention on the unconference, for those who haven't seen the list of unconference, at 3:30, there is an unconference specifically about platform engineering, I think organized by Lian, but I'm not sure. But anyway, I'll definitely be trying to be there, so we can also discuss more about platform engineering there. So 3:30 on the unconference. Yeah, you had a question there.
Yes. Thank you, Dotan, for a very nice presentation. It looks quite interesting. Do you have some other tricks how to encourage the development teams to start looking more into this like DevOps stuff and the platforms that we build for them?
Can you repeat the question? How can you encourage?
Do you have some other tricks how to encourage product teams and developers to look into this DevOps stuff?
So I think the main hook to get that is the toil, the pain that they experience. If you can get and show them, and sometimes they're not even aware how much toil, how much waste there is, how much time they invest redoing that. So that's why I showed, if you remember the case study that I showed with Citrix, that the first point is not to go straight up and in the implement. And I'm just looking for this slide that I showed. It's not straight away when you identify something that you think is potential here, this one, to go straight away and implement. First, go to the team, quantify the benefits, show them what they invest, what they have invested already, and what they're going to invest further to maintain it. And then show them the alternative if you provide it as a managed service, taking it off their hands. So both in investment time, also cognitive load time, you won't be needing to know all the details about Docker and so on and so forth. This value is the value that will show them the benefit. And after you get the buy-in, only then go and implement. This is, again, part of the treating it as a product. Don't jump to implement before you get the buy-in, before you characterize, and then you have your alpha, if you want, the design partner within your organization. And afterwards, you have a reference that you can show other product teams that you can use to extend it throughout the company. Thank you. Great question. Any last question? No, we don't have time. So thank you very much for joining me, and happy to answer questions also after this.